Good afternoon. I'm Michael Buser, and I currently serve as the National Program Leader for Engineering at the USDA Agricultural Research Service, or ARS. I also serve as the National Leader for the USDA's Partnerships for Data Innovations Program, or PDI. This afternoon, I'll give a brief overview of ARS, talk a little bit about the issues that we have with connectivity within ARS, introduce our USDA PDI program, and we'll spend most of our time discussing one of the rural broadband and precision ag data visualization tools that PDI has developed over the past couple of months. ARS is one of USDA's chief in-house scientific research agencies. We are currently working on more than 690 research projects within 15 national programs. When fully staffed, we have about 2,000 scientists and postdocs and roughly 6,000 additional employees that support our research mission. We have 90+ research locations in the United States and 4 overseas laboratories. Our scientists are supported with annual appropriations from Congress. Our scientists are actively collaborating with university researchers, and these research efforts are generally funded through competitive grants. Our research in ARS includes 4 program areas: nutrition, food safety and quality, natural resources and sustainable agricultural systems, crop production and protection, and animal production and protection. Within these program areas, there are 15 national programs that range from plant genetics to animal health, to watershed management, to food safety. ARS has a highly diverse research portfolio. Through our 690+ research projects, we collect petabytes of data annually. This data includes a wide range of data. For example, meteorology, soil moisture, UAV, production management, yield, quality, and much more. Our scientists are actively developing decision support tools and models to support our stakeholders. And since we are a stakeholder-driven agency, our scientists are looking for effective ways to engage their local, regional, and national stakeholders. ARS is a collaborative agency. We highly encourage our scientists to collaborate with universities and other federal agencies, state agencies, industries, nonprofits, and others. When our locations have connectivity issues, it directly impacts our ability to effectively do our day-to-day activities. It fosters an environment of data silos and using paper and pen versus inputting data into tablets or smartphones. It impacts our ability to engage with our stakeholders, and it slows down the advancement of agricultural research. Connectivity is an issue for agricultural research, just like it is an issue for many of our farmers and ranchers across the United States. We have 90+ research locations and more than 135 total work sites across the United States. The green pins in this map represent the work sites, and the red burst represent our area offices. Many of these locations have connectivity issues. For example, in Fort Supply, Oklahoma, we have the Southern Plains Experimental Range. This range is roughly 5,000 acres and has very poor connectivity. According to the FCC data, the census block where the range is located has median speeds of 10.2. Based on my personal experience, I think this estimate is fairly high. Looking at the left-hand image, the station headquarters is the white dot that is to the left and up a little from the center of the image. As another example, I have selected our National Peanut Laboratory in Dawson, Georgia. In the image on the left, the peanut lab is the large red dot in the lower right-hand corner. Some of our fields that our ARS researchers work on are in the middle to the upper left part of the image. The interesting thing about this location is the FCC data indicates that the laboratory has pretty good connectivity. But where our fields are, where we conduct research, there is a median speed of 6.1. So we are facing some of the same issues that many farmers and ranchers are facing: spotty and unreliable connectivity. For agricultural research, poor connectivity leads to other issues. Data silos keep researchers from sharing or accessing data. Data gets handled multiple times, creating inefficiencies in the movement and storage of information. Because of connectivity issues, research ends up relying on paper and pen that can lead to terabytes of valuable data being hidden in binders or isolated on bookshelves. Connectivity issues limit collaboration. which can hinder our national efforts to standardize data collection protocols. The USDA PDI program was developed to address many of these issues. PDI is focused on identifying or developing innovative data management solutions that can be deployed and maintained on a national scale. These solutions include improving connectivity. A year ago, we launched a data management streamlining effort called Partnerships for Data Innovations, or PDI. PDI was developed because agricultural researchers and our industry stakeholders have questions like, why don't we standardize our data collection methods? Why don't we integrate our data into a cloud platform? Why don't we integrate our agricultural production and conservation management tools and outreach materials into a common cloud platform? Why aren't we using more automated data collection, processing, storing, and distribution methods? Our agricultural research communities are asking for solutions to address these issues so we can move agricultural research forward at a much more rapid pace. Our stakeholders are asking that we develop these types of systems so they can easily find trustworthy data, decision support tools, and educational materials to help them be more productive while preserving our natural resources. Through PDI, we are working to innovate the way we collect, handle, process, store, analyze, and share data in this big data world. The effort has resulted in launching of a new online workspace for sharing and interacting with multiple data sets. The Agricultural Collaborative Research Outcomes System, or AgCross, is envisioned as a one-stop shop where you can find and share data that are standardized and interoperable. AgCross provides a key way for you to collaborate with other scientists, gather data, and utilize high-performance computing resources. Finally, PDI effort leverages the power of public-private partnerships, bringing shared tools and resources together to maximize our research, relevance, and impact. Unfortunately, I don't have enough time to dive deep into the schematic, so I will discuss it at a high level. Items in the green boxes represent data management solutions that PDI is actively working on today. We think about the components highlighted in the green boxes as a one-stop shop for agricultural researchers. These include expansion of the AgCross data platform, developing linkages to external data platforms such as Ag Data Commons, NOAA, USGS, and others, developing customized data collection apps for observational data, developing linkages between continuous monitoring sensors and AgCross, developing optimized regional laboratories for common sample analysis. All of these items rely or can be improved on reliable connectivity, and addressing our current connectivity issues begins with evaluating current available data. Patrick Ryan is a solution engineer with Esri and one of our PDI team members. Patrick is going to give you an overview of our broadband and precision ag dashboard that has been developed over the past few months. Patrick will talk about a couple of other tools, including a citizen science or crowdsourcing tool. Patrick, I'll turn it over to you.
So thanks, Mike. I'd like to take a couple minutes to share some examples of some really innovative information products that have come about from partnerships like the one with PDI. And then one map I'd like to look at some work we've been doing around precision agriculture. So we're looking at the same broadband FCC score here. So counties that are outlined in red have median speeds below that FCC standard. And in green, we're seeing the percent of these big five agricultural commodities. And these are crops that lend themselves more to precision agriculture sort of operations where broadband would be a very important thing. So let's zoom in to Arkansas here. And we can see our indicators say that there's quite a lot of agriculture going on and median speeds that are just above the FCC standard. And then taking that a step further, we'll zoom into a county here. And we can look at it. Arkansas County has almost 50% of the county's total land area in these 5 crops, but speeds that are well below the FCC standard. So this is work that the Agricultural Research Service at USDA is doing to, again, help inform precision agriculture. And this is a public-facing dashboard that you all can make use of as well. So next, I'd like to take a moment and look at the FCC Form 477 fixed broadband deployment data, just to explain a little bit about what it is. So this is the data that the telecommunication providers are required to file with the FCC twice a year. It's essentially just a list of the census blocks in which they can or do offer service to at least one location, and that details of the service, the download and upload speeds, and the transmission technology. And so this is what the data looks like in a table. And it's a vertical file. And you can see here in the yellow outline, just one census block and the 8 different service offerings that are there. So this is a very difficult table to work with. And what Esri has done is summarized it and made it available in the Living Atlas of the World. And I'm going to walk through now some different uses for that data. This is the FCC 477 data, and I recognize there's a lot of limitations to this data. There's still a lot that we can gain from this. So I've heard that oftentimes the 477 overstates broadband availability, but I've never heard anyone say that it understates. So here we are querying a census block outside of Colorado Springs, and in those, again, blocks in purple show no service at 25.3. And we're also able to see who the providers are in that area. So with the Data Act that the FCC just passed, they're looking to seek public comment to help improve these maps. And so a data set like this would allow a community to come in and say, who are the providers in this area? What technologies are they using? So we see here that we have a mix of DSL, cable modem, and fiber. And maybe provide some feedback to the FCC to improve these. Another way that you could look at this data is through the predominant transmission technology. So looking at that same area in Colorado Springs, we can see that around Cascade, cable modems, the predominant transmission technology. And up in Woodland Park, there's some fiber offerings, but in between, we're still using DSL and a lot of satellite. So this would allow a locality to kind of see the infrastructure that's in place and maybe how they can build out on existing infrastructure. Maybe stepping out a little bit, everyone wants to get a more granular look, but here we're looking at median speeds for US counties. And what we have here called the FCC Broadband Score is just an index based on the FCC standard of 25 megabits per second down and 3 megabits per second up. So with a map like this, we'll zoom into where I call home in Virginia, and we'll query Loudoun County. And so we can see that the county has a broadband score of 100, which would be expected with median speeds of 25.3. What is also unique, and I would contend useful in this, is we're able to see how Loudoun ranks amongst other counties within the state. So out of the 134 counties in Virginia for download speeds, there are 44 counties with better speeds than Loudoun. And it kind of ranks in the middle in terms of overall download speed categories. And then for upload, there are 56 with better rankings. And again, it's on the higher end of the overall speed categories. So taking this a step further, we're looking at, again, this FCC broadband score, but we can confirm whether or not that's what people are actually seeing by aggregating speed tests. So with that same methodology, we're looking at an UCLA score. So a county with speed tests of 25.3 would have a score of 100. So let's zoom into Kentucky here, and we can see a very similar look to maybe even a better result with the speed test. But what's I think very useful is comparing the two scores, and this is what I call the advertised versus the actual. So here we're looking at the FCC score minus the UCLA score. So a county in this case in pink is going to have advertised speeds that are higher than what folks are actually seeing through speed tests. And we've done this at various geographies. So we'll zoom in here until the tracks turn on. And actually, let me step back out a bit and poke one of these counties, and we can kind of get an idea of how that works. And so when the pop-up draws here, you can see we've got a very high FCC score, but a much lower UCLA score. And so that difference is quite dramatic here. So this is just a means for a county to come in and see what the FCC's representing and what the speed tests are actually showing. And then we've again done this all the way down to the block group, where you can see what parts of Boone County in this case actually have big differences and what are doing better.
And finally, I'd like to show how we can leverage ArcGIS dashboards and Survey123 to validate this data with actual on-the-ground speed tests. So here we have a dashboard with an embedded speed test, which we can run, and then we can invite our contributors to enter that data into a survey. So here we can see I'm on a fixed wireless connection, so not the best speeds, but it is a residential location. We are using the internet available here, and then we just fill in the results of the speed test. We also can ask additional questions like the type of service. So as I mentioned, I'm on a fixed wireless connection here. I am on an Ethernet connection to my laptop. And then we can submit this dashboard, populate with the results and update accordingly. So this is just another way that we can take that FCC data and validate it through crowdsourced actual on-the-ground speed test results.
Thank you, Patrick. That was a great demo. I want to follow up on a couple of items related to the broadband and precision ag dashboard that Patrick demoed. First, the crop data used in the dashboard is pulled from the USDA National Agricultural Statistics Service crop data layers. Although you see corn, cotton, rice, soybeans, and wheat on the bottom of the dashboard, you can zoom in to see other crops. For example, if you select California and Fresno County, you can zoom in and turn off the FCC data and turn on the crop data layers to see a wide range of crops identified in the legend. In addition to the crowdsourcing tool that Patrick demoed, we are working with a university partner to develop low-cost sensor solutions for monitoring connectivity speeds. The idea is that these data can be pushed up into our cloud platform and shared through a dashboard. We are working to drive the cost down so we can deploy possibly thousands of these sensors across USDA locations and possibly in USDA vehicles. When we develop these types of tools, we rely heavily on outside input. Hopefully, Heather can see many of her suggestions showing up in these tools already. We are interested in continuing the development of these tools and would like your input on additional data sets that we should include, additional features that you think might be helpful, or features that we currently have that you think should be modified or eliminated. I want to thank you for your time today, and if you would like to share your ideas on how we can improve the data dashboards or crowdsourcing tools, please send me an email at michael.buser@usda.gov or pdi@usda.gov. Thank you.